Okay, so 10.2 is evaluate and graphing the exponential functions. Exponential function is the function of the form y or f of x equal b to the x, where b is greater than 0 and b cannot be 1. Well, if it's 0 to the x power, it's going to be 0, right? Or if it b equal 1 and it's 1 to the x, it's still equal 1. So those are constant function. Is no longer exponential, right? So we need b to be not equal to 1, and it has to be greater than 0. So what does that mean? That means on the number line, you don't have to write this down. So go from negative infinity to positive infinity. Here's 0, here's 1. Anything but these two. Anything but these two numbers, right? And well, it had to be, it cannot be negative also, right? So it can be between 0 and 1. It can be between 0 and 1, and it can be greater than 1, right? Just as long as it's not negative, it's not 0, it's not 1, right? Okay, right. Now, for the domain of the exponential function, the domain will be go from negative infinity to positive infinity, and the range is go from 0 to infinity. Of course, it's not include 0, right? We'll take a look at the graph later why to double check for the domain and the range. And a lot of time I call B is the base. So let me write some note here for you, where B is the base, right? It is a constant, right? X is the exponent. Okay, so that's exponential function definition. Now, there are two cases for the exponential function. The first case is where b is greater than 1. Remember what I think I delete that. What I draw up there earlier, were two cases, right? Let me draw it again. Negative infinity, positive infinity, 0, 1. It cannot be this or this or this, right? But it can be either between 0 and 1 or greater than 1, right? So that's case 1. Here's our K1, and here is our case number 2. So case 1 is where b is greater than 1. So b greater than 1 would be what? 2, 3, right? 2.5, 2.6, 3.9, stuff like that, right? Any number that greater than 1, then the graph is called exponential growth. Let's see why it's exponential growth. So first, if you don't know how to graph anything, your best bet is plot some points, right? So let's plot some point. Here x, here y equal to 2 to the x. So let's plot some point. I got negative. So let me pick some point. -2, -1, 0, 1, and 2. When x equal -2, what happened? -2 to the x, which is, I'm sorry, -2 to the 2. Well, that 2 is always, well, the only thing that we replace here is x. I'm sorry. So 2 to the -2, right? Which is the same thing as what? 1/4. Yeah, let me write it slowly. 1/2 squared, which is 1/4. Do you remember this? Let me remind you. A to the -m is equal 1/a to the m. Yes. Okay. All right. Or you can use a calculator, right? When x equal -1, what's happened? When x equal -1, y equal 2 to the -1. So that means 1/2, right? When x equals 0, 2 to the 0 is 1. It's not 0. 2 to the 0 is 1. And when x equal 1, 2 to the first is 2. When x equal 2, 2 squared is 4. So let's grab some function. Okay. Yep. So let me see. Let me do some scale here. 1, 2, 3, -1, -2, -3. 1, 2, 1, 2, 3, 4. Okay, so when x equal -2, y is 1/4. -2 right here, -2, -1, -3, 2, 1, 2, 3, 1, 1, 2, 3, 4. Okay, when x equal -2, y equal 1/4. So it's right here, roughly. When x equal -1, y equal 1/2, a little bit higher. When x equals 0, y equal 1. 1/4 maybe down here, 1/2 is right here, and 1, 0, 1 is right here. Right. 1, 2 right here, and 2, 4 right here. Okay, now connect the dot. You notice that I don't touch the x-axis. By the way, this graph not supposed to touch the x-axis. And the x-axis is supposed to be your, what they call is horizontal asymptote. And I'll tell you why. It's because the horizontal asymptote is determined by the number that being added to the function. So here is 2 to the x. I can rewrite it as 2 to the x plus 0, right? So the horizontal asymptote, HA, is y equals 0. Right, so y equals 0. I can let me do a little dash line. When it comes to the asymptote, I prefer dash line. Right there. Right, it's right on the x-axis. And that's y equals 0. Okay. It's not always 0, but in this case, remember if b to the x is b as nothing else, then the domain is go from -infinity to +infinity. You can see that, right? Domain is your x values. You see the graph is stretching out from -infinity to +infinity. What about the range? The range is your height. The range is your height. So the height is, well, it's go from somewhere near 0, right? Never touch, never quite at 0, all the way to infinity. Right? Okay, so this graph right here, let me bring out a color here. Maybe I'll use dark blue. Okay, so the domain for the exponential growth is still from -infinity to +infinity. The range is, as you can see, from 0 to infinity. Now, the domain is always -infinity to +infinity, but the range can be changed, right? Depend on how your graph shift. Either shift left or I'm sorry, it's shift that up or shift down, right? Right now, because the horizontal asymptote is y equals 0, so from 0 onward, right? But in the later on, we're gonna shift the graph, so the domain will shift as well, right? Okay, so it is called the exponential growth. It has no x-intercept. It has no x-intercept. Yeah, put the little bullet point. No x-intercept. Is there a y-intercept? Yes, the y-intercept is 0, 1. And that's 0.01 is very important. That's why 0.1 is very, let me make it big because we need to remember that point. And then we call the exponential growth. Exponential growth, all right? So exponential growth is the exponential graph b to the x where b is bigger than 1. That's it. And it had that look. Increasing from left to right. Now, for the exponential growth, like the name suggests, this is the model to represent like the growth of population or the growth of the bacteria, right? Or if you have you ever heard of YouTube viral video? This is what happened, right? Day one, there's a few views. Day two, a bit more. Day three, a little bit more. But then when it go to maybe day 5, day 6, it's a lot of views, right? So the graph shoot to the infinity. Right? So this is what we call is viral video, and this graph can represent that. Right? Exponential decay. Exponential decay. F of x equal b to the x still, but now b is between 0 and 1. What number is between 0 and 1? Well, there's infinitely many, right? It could be 1/10, 1/2, 1/5, 1/7, right? Infinitely many numbers. But just let's take a look at just one, y equal 1/2 to the x. And again, let me do a little table here to see what happened. Okay, so x means, and then y equal 1/2 to the x. Same thing, I'm going to pick -2, -1, 0, 1, 2. I'll use calculator to do this right here. Come on. Here we go. Clear. So y equal, clear that. 0.5, 1/2, I can say 0.5, or just do 1/2, 1 divided by half to the second power. To the x, I'm so sorry. Oh, to the x. All right. Second table. Say -2 is 4, 2, 1, sorry. -1, delete that. -1 is 2. What about 0? 1, right? And remember, anything to the power of 0 is 1. 1 is 0.5. 2 is about quarter. Exactly a quarter, actually, 0.25. So 4, 2, 1, 0.5 quarter. Maybe I'll say 1/2. This is a quarter. If you notice, it's kind of going backward from up here. Right? Make it red. Okay, so let's graph this. -2, 4. 1, 2, 1, 2, 3, 4. -2 is 4. -1 is 2, right here. 0 is 1. And then 1/2. 1, 1, 2. 1 is 1/2. And 2 is 1/4. Graph. Again, try not to touch the. Just get close to it, but not quite touching it. Right. By the way, don't do like this. Don't go backward like that, like a parabola. Okay, it's not correct. It's get very close to 0. The further it goes, it get closer and closer to 0. Right, but we're not gonna go to infinity. We can't. So So try to get close to 0, but never quite touch y equals 0. Okay. So as you can see, is exponential decay. So go from left to right is decreasing, and it's decreasing really fast. Right, decreasing really fast. So I think they use this to do carbon to determine the age. I think carbon dating. Yeah, carbon dating for archaeologists and whatnot. It's pretty much the similar graph to the exponential growth, but is mirror image over the y-axis, right? You just kind of flip it over the y-axis, you get the exponential decay. Right? Notice that the horizontal asymptote is still y equals 0. Why? Because again, remember the horizontal asymptote is determined by whatever number is being added to the function, right? So here is nothing, so I can rewrite it as 1/2 to the x plus 0. So here is your horizontal asymptote, y equals 0. That's why it's 0. Again, if you shift it, if I add 1, it's going to shift up 1. If I add 2, shift up 2. If I add -3, it shift down 3. Right? We did transformation before. And again, it's going to come in very handy later. On the exam, I'm not going to ask you to plot point. Just know there's no point doing this. But I gonna explain it to you, okay, in order to go to the next step. So let me draw the horizontal asymptote. Right there, y equals 0. Some note about this. So domain, you can see domain is all real number, right? Go from negative infinity to positive infinity. What about the range? Pretty much the same, right? Go from 0 to infinity. What about is there x-intercept? No, there's no x-intercept. Again, we don't touch the x-axis. No x, no x-intercept. Y-intercept, 0, 1, right here, 0, 1, 0, 1. And it is called exponential decay. Right? Okay. All right. So for the next one, I'm going to show you how to graph this by transformation. Okay. Transformation. So here I have y equal 2 to the x minus 3. As you can see, the base is 2, so it's bigger than 1. So I know that it is a exponential growth, right? So this, I know that is exponential. Maybe I use black. B is equal to, which is bigger than 1. So that's imply if the exponential growth, So the basic graph of the exponential growth, y equal 2x, 2 to the x, it looks like this. It's go through 0, 1. We talk about that, right? And it's increasing from left to right. 0, 1, 0, 1. Okay. Now, 2 to the x minus 3. We're gonna x minus 3. We're gonna shift to the right 3 units. Remember the transformation? If it attached to x, you kind of shift to opposite for what you see, right? If it minus, you shift right. If it plus, you shift left. Unlike vertical shift pretty straightforward, right? You shift up if you adding, you shift down, you subtracting. So here is you're gonna shift to the right 3 unit. So where do not start from the origin. You start from 0, 1. That's what I said. 0, 1 is a very important point. You start from 0, 1. You go 3 units over. 1, 2, 3, right there. And then copy and paste. Again, this graph have a horizontal asymptote is y equals 0. because there's nothing add to it, right? Now your new, I don't want to call it vertex, but the new point is it's going to be 3, 1, right? It's going to be 3, 1. That's your new point. That's what I'm expecting when you shift your exponential function. I want you to give me the new points. Okay, so so this one right here, I can rewrite it as y equal 2 to the x minus 3, what? Plus 0, right? That's why the horizontal asymptote is still y equals 0. So this implies the horizontal asymptote is y equal 0. Y equals 0. Okay. Why don't you pause my video a little bit, and I want you to graph these two graphs, see what happened on decimals. So let me share my screen in decimals here. Okay, so as you can see, y equal b to the x. If b is bigger than 1, say b is 2, you can see, right? It's go to 0, 1, and it's increasing from left to right. Now it's here. You see that it's look like it's touching the x-axis, but it's not, right? If you keep zooming in, see, it never touched. It's never touched the x-axis. It never quite did. Never did. Get very, very close though, but never did. Oops. Zoom that so I can see the whole thing. Okay, so if b is less than 1, you can see it's changing. Now it's decreasing, right? If it at 0 or 1, say if it no, if it's 0, b equals 0, 0 to the x is 0. That's boring, right? Nothing happens. It's just a line, right? What about 1? B equal 1, y equal 1. Right there. It's just a constant function y equal 1, right? It's nothing special. So b had to be greater than 0 and had to be bigger than not equal 1. Okay, so here is y equal 2 to the x. 2 y equal 2 to the x minus 3, as you can see, let me mute this one, is shift to the right 3 unit, right? So instead of 0, 1, now it go to, come on, right there, 3, 1, 3, 1, right? 3, 1. I asked you to graph. Try yourself, y equal 2 to the x and then plus 3. Now, notice that this graph, rather than red, this one and this graph, the red one, the x is not, the number 3 is not being attached to x, right? Rather is being attached to the whole function y equal to x, right? So that's when you know you have to shift vertically. And when you shift vertical, it's very straightforward. If you add, you shift up. If you subtract, you shift down, right? So compared to the basic graph is this one, right? You shift up 3 units. So from 0, 1, you count 1, 2, 3. So now the new one is 0, 4. And can someone tell me what is the horizontal asymptote here? Remember, horizontal asymptote is some number that being added to the function. Well, 3 is being added to the function, so the horizontal asymptote will be y equal 3. Right there, right? Y equal 3. Again, this red graph should not touch the dotted orange, right? Because that's the horizontal asymptote. The second one is y equal x minus 1 and then minus 2. So that means you shift to the right one and then you shift down 2, right? So from the basic graph here, always start at 0, 1. You shift and you shift to the right one. So shift right 1 and then you shift down 2. 1, 2, right here. Oh, come on, let me, sometimes it let me, it's negative 0, let me do this. -1, oh, not 1, come on, -1, right there. Label, okay. See, that's what I'm, and then the horizontal asymptote will be something that being added to the function, and that something here is -2, right? So y equal -2 is your horizontal asymptote. So compared to the origin, as you can see right now, the domain is always go from negative infinity to positive infinity, but the range is changed, right? It used to be from 0 to infinity. Now it's go from what? From -2 to infinity, right? So the range is depend on the vertical shift. On the exam, this is what I'm expecting you to do. I'm gonna give you a function, and then I'll give you the basic graph. I'm asking you to do transformation like we did last time on the exam 2, right? Shift left, shift right, shift up, shift down. And then at the end, you need to label the point for me and also graph the horizontal asymptote as well. All right? Preferably in dotted line. Okay, so the last one, if you look at the lecture note, I have y equal pi to the negative x plus 1 minus 4. Well, this graph is kind of wild, right? But if you think about it, pi is what? Pi is 3.1415. Right? So it's just a number, right? And that number is bigger than 1. So I know it's a exponential growth, like exponential growth. Now, the negative x plus 1, this one a little bit complicated. So let me show you how to do this by hand first before you use the decimals. Again, we know pi is 3.1415 something. So it's the point is bigger than 1, so it's a exponential growth. So that means I'm going to use the exponential growth graph, right? Exponential growth graph will look like this, roughly, right? Roughly. Go through 0, 1. All right. And then let me break this down. Let me rewrite this. This one I can rewrite it as pi. I'm going to factor out the negative to the top. So it's going to be x minus 1 here. You agree with me? After I factor out the negative 1. Right. Now, first I'm going to graph y equal pi to the negative x first. Pi to the negative x, it looks like what? This is the same thing as 1 over pi to the x, right? You remember the rule that I told you? Is a to the negative m is equal 1 over a to the m, and I can go backward like that, right? So if you take 1 divided by pi, it's going to be something between what? It's going to be between 0 and 1, right? It's going to become a decaying graph now. Decaying graph is just the mirror image over the y-axis compared to the growth graph. So it looks like this. I'm going to do dash like this is not my final graph. Again, it's not supposed to touch the x-axis. So this right here is y equal pi to the negative x. So far, so good. Now, what about pi y equal if you graph this one, if I add -1, what happened? Maybe I'll use run out of color here. I'll use pink. Yeah, I'll use pink. How's that? I'll use pink. Y equal pi to the negative x minus 1. The -1 telling you to move right 1 unit, right? So from the blue graph, I'm going to shift 1 unit to the right. So shift to here. And that's now this will be my new graph. Again, it's not the final graph. And still the horizontal asymptote is still y equals 0, right? Okay. Now if you add 4, what happened? From the pink graph, now the red graph, y equal pi to the negative x minus 1. And then you add 4. What does it mean when you add 4? You move down 4 units. I'm sorry, you move up. I add 4 minus 4. I'm sorry, I subtract 4, add minus 4. So you move down 4 units, right? So from 0, 1, or from 1, 1, you count from the pink one. 1, 2, 3, 4. Now that's your new graph, right? So I'm gonna, and what is it, my horizontal asymptote? Horizontal asymptote is this one right here, right? Y equal -4. So let me graph my horizontal asymptote before I graph my graph. So I know I don't touch it. Now I'm gonna copy and paste from the pink one. Your final graph right there. Y equal pi to the negative x minus 1 minus 4. Okay. So one step at a time, one step at a time. If I give you something like this on the exam, again, one step at a time, right? Don't think too much. And let's take a look at the decimals. See if we got it right. Sure. Right there. I think we got it right. We got it right. Your new point right now, I forgot to put the new point. New point right now be 1, -3, right? One, -3. Right there. 1, -3. And then the horizontal asymptote is y equal -4. Right there. So we got it right. Very good. Now, natural exponential function. It's just a fancy name of having a somewhat a special exponential function. This is a special exponential function, and it has the form y or f of x equal e to the x. Right. Again, e is the transcendental number. It's kind of like pi, right? By the way, the value of e is equal, where e equal 2.7182818 something, 18. Yeah, so it's go on forever and forever. It's kind of like pi, you never repeat it, right? It's transcendental number. So the point here is e is bigger than 1. So it is an exponential growth, right? So the domain is pretty much the same. If I have f of x equal e to the x, right? Or if it better for your brain, you can write it at 2.71828 something, right? To the x power. It's the same thing. The point is bigger than 1 is exponential growth, Right? So the domain is from negative infinity to positive infinity. Let me use red. And the range is, again, the same thing as 2 to the x, 3 to the x, is from 0 to infinity. And you're shifting the same way, right? You're shifting it the same way as the exponential growth. So let me put a little note here. Transformation means shifting. Is the same way as the exponential growth graph. But because 2.718 is bigger than 1. Okay. Maybe I'll show you. Maybe I'll show you on the decimals a little bit. Okay, so let me mute these. Y equal e to the x. Oops, e to the x. Okay, if you notice this, the black one is y equal 2 to the x. The blue one is y equal e to the x. You notice that e is 2.17. I'm sorry, 2.18, 2.71828, etc. Right? And then and it's bigger than 2. So the function is grow a little bit faster. So you notice that the blue function grow a little bit faster compared to the black function. Right? The bigger the base, you grow faster. Just makes sense. And that's all. If I want to do, say, for example, y equal e to the x minus 1 right here, again, it shift down 1 unit from 0, 1. It should have 1 unit from now is 0, 0. Right? And the Horizontal asymptote is y equal -1. Right there. Right, y equal -1. So it should very much the same way as the exponential growth. All right. Okay, last thing about this section. Yay, last one. We're gonna solve exponential equation. So here is a step. Just for example, to solve 2 to the 3x minus 8 equals 16. First, you write both sides of the equation with the same base. So on the left hand side, I have base 2. Yeah, 2. Let me use red. 2 to the 3x minus 8. And please write the 3x minus 8 on the top. Don't write it down. It meant different thing. Now, the number 16, I want to write it as base 2. 2 to the what power give you 16? Use your calculator. Right? Just multiply 2 by 2 by 2 by 2. See how many times you multiply 2, get 16. That would be 2 to the 4. So we did that. We did step 1. Write both sides of the equation with the same base. They both have base 2. Second step, write the new equation by setting the exponents equal. Now, if 2 to the 3x minus 8 equal 2 to the 4, well, the base is the same, and this is the equation, they equal, so this implies 3x minus 8, it has to be equal to 4, right, for this equation. And now you solve, so you add 8, now you saw like you know how to solve before. That's 8. I got 3x equal 12 divided both sides by 3. X equal 4. And now you check. Now you can check. Let's check. Let's check. Let's check. I'll check in blue. 2 to the 3x x is 4 plus, is it plus or minus? Minus 8 is it equal to 16. Well, 3 times 4 is 12. 12 minus 8 is 4. Right? 12 minus 8 is 4. So 2 to the 4, it is indeed equal to 16. So check. You can check this with your calculator. Okay, so you can pause my video if you want, and then try to do the rest. But let me show you how to do these. Okay, so the first step is write both sides at the same base, right? I have 1/3 2 to the x minus 1/3 to the 2x minus 3. Now on the right hand side, I have 27. 1/3 and 27, really? Well, 27, I can rewrite it as 3 cubed, right? The 3 cubed is 27. But I don't want 3, the base 3. I want the base 1/3. How do I do that? How do I do that? Well, maybe I'll leave the right hand side like that. Maybe I'll change something from the left hand side. You notice that again, this is the same rule I've been telling you. A to the negative m equal 1 over a to the m, right? So if I have here on the left, on the right hand side, I have 1/3 1 over 3 to the first. If I want to write it at the base without the fraction, how do I do reverse engineer? Well, a is 3, right? 3, m is 1, but instead of 1, you're going to have -1. So 3 is the -1. Okay. So on the left hand side, I can just write 3 to the -1. And then outside, I have 2x minus 3. Now you can multiply the two numbers together, right? Remember, recall again, if I have a to the m to the power of n is equal a to the m times n, right? So same thing here, it's going to be equal to 3 to the -1. Maybe I'll use blue still, to the -1 times 2x minus 3, right? And that equal to what? That equal to what? 3 to the -2x plus 3, and then bring this down here, equal 3 cubed. Now we have the same base, right? 3, 3, we have the same base. So we set the exponential equal, so this implies -2x plus 3 should be equal to 3. And then solve. Subtract 3, -2x equals 0. Divide both sides by -2x equals 0. And if you check back, it should work, right? If you check back, it should work. 0 for x. So 2x times 0 is 0. 0 minus 3 is -3. 1/3 to the -3. 1/3 to the -3 is equal to what? If you change the first rule again, right? First rule again, I can change it at 3 to the -1. And then -3 out, still -3 outside. -1 times -3 is +3. So 27. Or you can use your calculator. Okay, maybe I'll show you how to use calculator check here. I'll show you how to use calculator right now. 1/3 2 to the x minus 3. Clear. Okay, so first of all, I'm gonna store the solution. The solution here is, I forgot already. The solution is 0. Okay, so I'm gonna store it. So let me show you how to store a number as a variable. So have you seen the store key right here? Store, STO, S-T-O, STO, right? And then there's the X key. All right, I want you to remember those two keys. Okay, so delete. So 0, first press 0, and then STO, 2x, so X, press X, and then enter. So now the calculator, remember X is 0, right? So if you press X next, and then you press enter, it spit out 0, right? Good. So now, okay, 1/3, so parenthesis 1 divided by 3, close parenthesis, to the power of 2x, 2 times x minus 3, right there. It's equal 27, right? When you store 0, x at 0. Right? So that means your answer, your problem is solving correctly. Let me box that. Last one. Is that the last one? No, not quite. Not quite. Solve the exponential equation. This one a bit more complicated. It'll need a bit of workaround. Okay, so my goal here is I need the same base, which is e. Remember, natural log is natural log e's. On the left hand side, I have 2e, and I just need it to be 1e. Again, let me remind you, the exponential rule. A to the m divided by a to the n is equal to a to the m minus n. I hope you remember. So a here is e, right? M is x squared, and then n is 3. So e to the x squared divided by e to the third is equal to what? E to the x squared minus 3. Minus 3. So that's what it is. E to the x squared minus 3. I think I messed up something. It should not be 2x minus 3 out here. It should be something else. No, it's, yeah, it had nothing. It's nothing there. So let me do this. Let me do this. Apologize. That make it even more complicated, which is I'm not gonna do that to you. So it's just that, it's just like that. So the original equation is just like that. Okay. Which we change into this. We change into this, right? And now we bring down the right hand side, which is e to the 2x. Okay, now we have the same base. All you do is just remove the base and the powers drop, right? So it's going to be x squared minus 3 equal 2x. This is quadratic, so what I'm going to do, I'm going to move everybody to the left and then just 0 on the right. So subtract 2x, that cancel. On the right hand side, I have x squared minus 2x minus 3 equals 0. X squared and 2x, and they're not the like term, you cannot combine, right? So just rewrite it. Factor this, x 3 1 minus plus equals 0. So this imply what? This imply either x equal -1 or x equal 3. That'll be your answer. You can check. You can check with your calculator like I showed you earlier. Okay. Compound interest formula. So one thing about exponential function is you use it to compound your interest. Now, if you buy a car, then they'll tell you how much interest you pay, right? This is the formula they use. Compound interest, right? Or if you invest into something like a stock, it's the last few years during the pandemic, a lot of new people who are involving in playing with stock market, right? So stock market is also have sometime, right, at the interest is being compound, right? The compound interest. What does it mean, compound interest? It means it grow very fast. It grow very fast, just like the exponential function, right? So So here is the formula. The first one is number of compoundings. So depend how many times you compounding per year. It could be annual, mean once a year. It could be semi-annual, it'd be twice a year. If it quarterly, it'd be 4 times a year, or monthly, it'd be 12 times a year. Okay. But daily is, you would think 365 times a year, but then they use 360. The reason being is back in the day, they don't have, they had to do things by hand. So 360 is easier to work with than 365. So, but here is the formula. The bottom line is the formula, where A is the current amount, B is your the current amount, or a lot of time the bank call it balance, right? P is your initial amount, or the bank call it principal. R is your rate in percentage, but in the problem, I want you to change it into decimal. T is your times, how long you invest, right? N is the number of compounds. Like I said, you compound yearly, semi-annually, quarterly, monthly, etc. So that's the compounding. Now, the other one, the one on the right, you see two formula. Is called compound continuously. Continuously. That means excuse my spelling. Continuously. That means instead of compounding yearly or compounding annually or semi-annually or even daily, you keep pressing, you keep hitting that computer. It's compound all the time. It's every moment of it, every second, right? Just keep pressing that enter key, your computer. Just keep compounding continuously. Then you use this formula. Okay. So let's take a look at the one of the application problem. Right. Now, for compound continuously is the same thing. We have A, it has P, it has E. Well, it has R, it has T. E is your transcendental number. Remember, E is 2.71828. Right. So here's a formula. Cynthia, here's one of the problems. Cynthia invested 12,000 in a saving account. If the interest rate is 6%, again, what I'm going to do right away is I'm going to change that 6% into 0.06. Please change it into the decimal. Otherwise, when you plug in the formula, it gives you something really big, which doesn't make sense. If the interest rate is 0.06, how much will be in the account in 10 years by each method of the compounding? First, compound quarterly. Compound quarterly, what? Quarterly mean n equal 4. Compound monthly, why so dark? Compound monthly is n equal what? 12, right? 12 months a year. And compound continuously, question mark. Compound continuously, maybe I'll use red. That means you're going to use this formula, the different formula, right? If they give you the number of compounding, you use the left formula. If they say continuously, you jump right to the right formula, right? So you're going to use PERT. I call it PERT, P-E to the R-T. Okay, so let's do this. A compound quarterly, right? So the formula is, oh, you know what? If I was you, the first thing I do is I'm gonna summarize the problem. So Cynthia invests 12,000 in saving, invest 12,000. So that means principal is, in the beginning, she got 12,000. If the interest rate is 0.06, interest rate is, R is 0.06. How much will be in the account in 10 years? So 10 years, that's T, that's time. 10 years. All right. And for A, they want you to find A, the balance, how much, when n equal 4. And for problem B, if they want you to find the balance again, but this time they compound 12 times a year, and see what is the balance when you compound continuously. Right. Okay, so let's do this. So the formula, right? The economic, because they give you numbers of compounds. So the formula is going to be this one. Same thing with B, right? So A, let me rewrite it here for you. A equal P parenthesis 1 plus R over N. By the way, you're not supposed to remember that. I'll give it to you on the test. To the N times T. And then plug it in. You plug it in. P is 12,000. And then 1 plus R is 0.06 divided by N is, in this case, is 4. And N times T, so 4 times 12. And I'll show you how to do it in calculator. Okay. All right, ready? Okay, so 12,000. Open parenthesis. You see the alpha and frac right here. I think I talked to you this before. Alpha, this one and this one, alpha and frac. Press that. Press alpha first, and then frac. But first we need 1 plus, and now you need fraction, right? R over N. So alpha frac 0.06, and go down is 4 over 2 to the 10 times 4, or 4 times 10, doesn't matter. And then press enter. So in 10 years, you're gonna make 21,768 and roughly 22 cents. We're gonna route it into the nearest cent. Right? So 21,768 22 cents. Of course, it's US dollar. Right. Now let me show you what happened if you don't change don't change 6% into 0.06. Go back here. Delete. I'm gonna put it 6 instead of 0.06. Look at how much she make. By the way, if you see the E to E19, that's mean let me write this. This means 9.926 something times 10 to the 19. That's trillion of dollars. That does not make sense. If it can make this much in 10 years, I'll probably not be teaching you right now. Right. So your answer has to make sense, right? After 10 years, she make roughly she could roughly double her amount, right? It just makes sense. Right. Okay, so B, let's do B, or you can do it yourself. B is compound monthly, so you still use the same formula. So now A equal 12,000, 1 plus 0.06, same interest, but now compound monthly, so 12 over N times T, 12 times 10. And on the calculator, I'm going to do a second entry because I don't feel like second enter to do entry, and then just change. Let me change this one. Delete 0.06. And then go over, change your number 4 into 12. Oh, I forgot to change the 12 in the bottom in the denominator as well. No wonder it looked so good. I should make it 71,000. Delete 12. Okay, now enter. All right, so roughly 21,832.76 cents. 21,832. What is a cent? 76. Make sure you round it to the nearest cent. All right. And what about compound continuously? You're going to use PERT, right? A equal P times E to the RT. So P is 12,000. E, don't put 2.71, okay? Just put E in the calculator. You have the letter E, just kind of like just how you have letter pi. R is 0.06, and then T is 10. So let's put that in the calculator. Now let me show you E. E is right here. All you have to do is press second and then the division key. So 12,000 first, and then second, E to the 0.06 times 10. 21,865.43 cents. 21,865. So 43 cents. Okay, so a little bit better. You compound, you look at three answers. If you compound quarterly, you compound. If you compound quarterly, you make yay much. If you increase the amount of compounding, you make it a little bit better. And if you compound continuously, you make it a little bit better. Okay. All right, that's it for today. Thank you for being patient with me. And then I'll see you tomorrow in room 124. Okay, it's the same building. All right, bye-bye.